Welcome everyone. This is episode 5 of Data Structures and Algorithms. We're going to be going over again the theory of linked lists. I promise we'll get to the code in a couple more episodes, but we need to lay the groundwork to begin with. So with that being said, let's begin. So the way we're going to be looking at a linked list is from a bottom-up approach. So the first thing we need to know about linked lists are that they are actually built upon by having individual nodes. So a linked list is just comprised of a bunch of nodes added onto each other, and that's how you get the list. Depending on how you have the node set up, as well as how you have the overall linked list set up, you can get some really good shapes which can help with optimization on harder problems. But we won't talk too much about that. So let's begin on what a node is. Well, a node essentially has some form of data. It could be an int, it could be an object, it could be a double, whatever your heart desires. But associated with that, you have a pointer which points to either null, as shown in the first on the top, or another pointer which is shown at the bottom. So you can have a class called a node with two variables in it, the data and the pointer points to null or another node. This can work together by being implemented inside of another list. So you have your little node, and the node is an object within the linked list. And inside the linked list, you also have this pointer called head. It is similar to a node as in it's a pointer, but it does not have any data. This head just tells you where the beginning of the linked list is. So as you can see, when you initialize a linked list, the head has no data associated with it, so at the top you can see that the head points to null. However, at the image below, you can see after you've added some data to the linked list, A, B, and C, that the head points to the first element added, and then that element points to the next element, and it keeps going down until you reach the end, and then the last element points to null. Now, there are different types of linked lists. We just talked a little bit about the simple linked list, where items only move forward. But then, if you update the node, you can have a doubly linked list, and then you can navigate forward and backward. Lastly, depending on how you want to implement it, you can have a circularly linked list where it circles back using the node, or it circles back using the head. We will only talk about circularly linked lists with the node. Now, a linked list has the node where you have the data and a pointer, and the linked list all point to null. And then, as you add on, you update the head to point to the first node added, and then, correspondingly, every pointer will point at the end, either points to null, or when you add another element, it'll point to the new node. For a doubly linked list, you have a node, however, it has a back pointer, which points to null, it has the data, and then it has a forward pointer, which also points to null. And then the linked list, again, initialized to null as well. If you wanted to see an example, we have one here, where the head pointer, shown as HP, points to the first node, the back pointer of the first node points to null, you have the data, the front pointer, as normal, points moving forward. Now for the second node, the back pointer points to the first node because 2 comes after 1. And then the forward pointer points to null again because that's the last element. So now you can traverse forward and backward in this doubly linked list. Moving forward, we have a circularly linked list, which is similar to a normal linked list, but instead of having the last element point to null, we have it point back to the first element. Now, there are some fun ways you can go about implementing this, but for the time being, we're just going to leave it at that. Now, how do we go about looking at a linked list and adding the last element? Well, the first thing we do is on the right side, you see we created some data, which is pointing to null. Well, in the linked list, we traverse all the way down until we hit the last element, and then we say that the last element, instead of pointing to null, now points to the new data, and the new data, which is the element we wanted to add to the last, is now pointing to null. Now, what if we just wanted to add a node at a specific place? Well, again, you'd start at the head, and you'd traverse until you have the next one either be null or the data that you're looking for. Because in this case, if we're starting at head, the next one will be the second one. The next will be the position we want to look for. So what we can do is we can trade out where the pointers point and say that the next points to the data that we're adding in, and the data that we're pointing in points to the next element. And again, when you do this, you always make sure that you haven't reached the end. But now that we know how to add to the end, or add at a specific location for a node in a linked list, what about if we wanted to remove the last element? Well, if we wanted to remove the last element, you traverse until you get to the second to last element, and you just say the pointer, instead of pointing to the last element, it points to null. What will happen is this last node now, which is shown here as 1, will become an orphan node, which means nothing is pointing to it and it is not pointing to anything. It is just there. So garbage collection is a really cool thing where it will identify this orphan node and get rid of it. And if we wanted to remove at a specific position, it would be similar to adding at a specific position. Instead, though, you will change the pointer to skip over it. And since this is, again, not having anything point to it, it will become an orphan node. Even though it is pointing to something, it is still considered an orphan node since it does not have any way of accessing the information. That's it for today. Thank you for your time. Have a nice day.